At what we were doing yesterday. We've got the rational function r of x equals to f of x divided by g of x. Hope you can see me. And basically what we did was we divided by 3x squared minus 12 divided by x squared plus 3x minus 4, and then we factorized it. Okay, this is what we factorized. And remember, from there we actually found the vertical asymptotes. VA stands for vertical asymptotes when the denominator equals to 0. That means that we can get either x plus 4 equals to 0 or x minus 1 equals to 0, and they will give us our vertical asymptotes. So, as we discussed earlier, we have vertical asymptotes at x equals to -4 and x equals to 1. Just so you're aware, if you can see this, because I know it's still not perfect and I'm still figuring it out for other things, other videos that I'm going to make with maths. VA stands for vertical asymptotes and HA stands for horizontal asymptotes, just for ease of reference. Now, if we were to look over here, we know that the x-intercepts are when y equals to 0. In other words, the numerator is irrational. The numerator of a rational function is 0. The top part, obviously, I know that we know what the numerator is 0. So that means in this case, we've got x minus 2 equals to 0 or x plus 2 equals to 0. Remember, these are our x-intercepts where y equals to 0, and the numerator is what defines this. Okay. So we've got our vertical asymptotes, x equals -4, x equals to 1. We have our x-intercepts, x equals to 2, x equals to -2. And we also have our horizontal asymptotes, which we can figure out by dividing f of x, which is the top function, divided by the bottom function, which is g of x, divided by the highest power of x in g of x, and then test what value the rational function will become as you go extremely large to positive infinity or extremely small to negative infinity. Okay, so we'll either have f of x and g of x have the same power, okay, whether or not it's 3x cubed minus 3. And then, for example, obviously we will divide by the highest power in the denominator. So we'll divide the top and the bottom by x cubed, which will give us x cubed over x cubed divided by 3x cubed over x cubed minus 3 over x cubed. Now, as x, firstly, on the top we're going to get 1, on the bottom we'll get 3, and 3 over x cubed. As x approaches infinity and we have 3 over something which is ridiculously large, we're going to get something which is essentially 0. So we can basically call this 0. Now we are talking about limits, but this is just an informal treatment at this stage. Later on we'll actually be looking at more extensively. That means our horizontal asymptote will be at 1/3. Okay? Now, we know at x equals to 2, we've got an x-intercept. We know at x equals to -2, we have another x-intercept. We know that x equals to -4. Okay, say this is -2, this is 2. Say down here we have a vertical asymptote. Now we're running out of room. Okay, and then basically what we can actually do is, if we have enough room, okay, so we need to see what's happening on either side. So we've got -4 and 1. Okay, those are our vertical asymptotes. Okay, so basically as we were discussing before, let's put this as -4, this is -2, 1 and 2. Okay. So if we look at, for example, let's test x equals to 0. When x equals to 0, we have 3 times -2, which is -6, times by 2, which gives us -12 on the top. and 0 gives us 4 times negative 1 gives us negative 4, which gives us 3. Okay, so basically our y-intercept is 3, and we know that this basically is acting like that. Now if we test negative 3, we should see that actually it's going down here. It would look like that would make sense, but I could be wrong. So let's test. This is a negative 3. When we have negative 3, let's just quickly do this. We can make it easier. 3 outside of 5 divided by negative 3, 1 times negative 4. It gives us 15 divided by negative 4, which gives us negative 4, negative 3 3/4, correct? Is that right? 15, negative 4, 3, 12, 3 1/4. Yep. Okay. So down here, we're looking at something like this. So I'm going to suggest like this. Now let's just, how can we be sure, Mr. Anthony? Maybe you're making this up. Test 0.9 or something like that. Put it in your calculator. Okay. I'm almost positive that it does this because it has to hit this y-intercept. And that y-intercept at x equals to 0 was 3. And we have our asymptotes acting in this manner. And it's always important to color your arrows in if you want to get full marks, especially if you stay in the lines. Okay, now, basically what we want to know is, we know it crosses here, but what happens at 1.1, for example? Well, let's just test x equals to 1.1. Very quickly, 3 outside of 1.1. Oh my goodness, I don't have a calculator. Yes, I do. Always have a calculator handy. Okay, so we've got, let's just do this. 1.1. Why have I got this on? Mark of a good mathematician is always talking to oneself. Hurry up. Sorry, I should be looking at the camera so I can actually see that I'm talking to you, but anyways. Feels sort of weird talking to myself. 1.1 squared, okay, minus 4, what? Oh, I see, 1.1 squared minus 4 times by 3, okay, so on the top here, okay, I get negative 8.37. And then on the bottom, I'm going to put in 1.1 also. And we'll get 1.1, 5.1 times by 0.1, just to give us an idea very quickly. And we should get 5.1 times 0.1 equals 2.51, negative 8.37 divided by 0.51. Equals to negative 16.4118, whatever. Okay, so basically we know that when we have 1.1, okay, just past 1, we are going down here. Okay, and then if we check at what we know, it goes through 2, but we need to find out what's happening over here. So let's just say we put in 4. Okay, so we test x equals to 4. I'll just check that you can actually see this. Okay, test x equals to 4. We will get 3 outside of 2 outside of 6 over 8 outside of 7. 1236 divided by 56. That means it's less than 1, obviously. Okay, so, and Mr. Anthony, you completely forgot about your horizontal asymptotes. And we found this is what called forgetting stuff. So this is why we couldn't think about what exactly is going to happen. We know that for our horizontal asymptote, which we discussed before, we will actually get 3x squared minus 12. We're going to divide both top and bottom by x squared, because that's the highest power of g of x, over x squared plus x squared plus 3x over x squared minus 4 over x squared. Okay, if you can't see that, you'll be able to see that now. Okay, that means that we will get essentially a horizontal asymptote at 3 minus 12 over a very large number is going to give us a 0 essentially. As x approaches infinity, we'll get 1 on the bottom there for x squared divided by x squared. We'll get plus 3 over x, 3 over infinity will give us a very small number, which is essentially 0. Minus 4 over x squared will essentially give us 0, so we'll have a horizontal asymptote at y equals to 3. Okay, which I forgot to put in, which is very... So before, I can't even remember, we did 1.1 and it was approaching 1, but it was less, sorry. We did, I can't even remember what we did. X equals to 4 and it was approaching 1. Obviously, it's getting bigger and bigger and it's actually going up here. Okay, and we know that it comes down here. If you check down here, I bet you will find out that it goes like this. Okay, it's approaching that asymptote. I'm going to cheat for 1 second and just check. Okay, and yes, that's exactly what happens. Now, one more thing, we need to draw this and get this out of the way so we can see what's happening here on the other side. So we test something like, for example, -5, okay, when x equals to -5, we know that r of x will equal to 3 outside of 25 minus 4 times 21. -5 plus 4 will give us -1 times by -6, which will give us 63. It doesn't really matter exactly, but it will start to give us a very big number, and this is at x equals to -5. Okay, so at x equals to -5, okay, we actually get a... Oh yes, you completely forgot, Mr. Anthony, you were assuming stuff. Okay, so we know that we get a massive number. So at -5, we know this is going to happen here. What about if we did -10? X equals to -10. We can check that and we will get 3 times 100 minus 12 outside of 100 minus 30 minus 4, which gives us approximately 288 divided by 100 minus 34 gives us 66. Off the top of my head, it's 4, 240, 264, 4 and something, okay? Okay, so we know it's basically coming down towards here and it's approaching our oblique asymptote. Now we have actually graphed it, and now we have finished our graph. We knew the x-intercepts at this point, okay, from the numerator. We figured out our asymptotes, our vertical asymptotes from the denominator. And we figured out the horizontal asymptote by dividing by the highest power of g of x, giving us y equals to 3. And from there, we tested values to see what happens. Okay, and that's actually the rest of that question. Over and out. Okay, we have a question. Let's check that my microphone is working. It is working. We've got a question where we've got power on the bottom that's, we've got a bigger power on the bottom, which is fine, okay? The only time we have oblique asymptotes is where the power on the top is 1 more than the power on the bottom of the degree. Okay, in this particular case, let's first look for our vertical asymptote. So in order to do that, let's factorize. Okay, that's the first thing that we need to do. I can't even know if you can actually see me, but hey, that's cool. Okay, so basically we have x minus 2 all over x outside of x minus 4. In order to find our vertical asymptotes, what we have to do is, remember, test this and let this equal to 0, the denominator. So we've basically got x equals to 0 or x equals to 4. Those are our vertical asymptotes. X equals to 0 or x equals to 4. Now we actually, that means factorize. If you can't see, that's an R, it's a dodgy R. Anyways, who cares? Okay, so we now need to look for our x-intercepts. We can figure out our x-intercepts by looking at this and finding out when this equals to 0. Okay, so x-intercepts, numerator equals to 0, x minus 2 equals to 0, therefore x equals to 2. Okay, that is our x-intercept. Now we need to test for our horizontal asymptote. Horizontal asymptote, in this particular case, we will just divide by the highest power of the denominator, which is x squared. So in this case, we'll divide through by x squared. Okay, do this for everything in the numerator, then do it for everything in the denominator. Okay, and remember we're looking at these values as x approaches a massive number and a small number. Okay, so it's very easy just to look at. You imagine that's a huge, massive number. So on the top we have x divided by x squared, which gives us 1 over x, sorry for the delay, it is late, minus 2 over x squared. Okay, on the bottom we will get 1 minus 4 over x. I hope you can still see that. Okay, and 1 minus 4 over x basically means that the top, this will become 1 over a massive number as x gets massively large, which will give us 0. 2 over a massive number will give you 0 essentially, and on the bottom it doesn't matter anymore, but we'll look anyways. 1 minus 4 over a massive number as x approaches infinity is essentially 0. We get 0 divided by 1, which gives us a horizontal asymptote at y equals to 0. Okay, so we've got a horizontal asymptote at y equals to 0. It could be better organized with my board, but I'm sure you can excuse me. Now, oops, not so sturdy these boards. Okay, so basically, what else do we need? We draw this, we say we've got a vertical asymptote, we check that the camera's still on and recording, and realize that it's actually a bit dark over here, so let's move it more this way and see if you can see it. Cool. Okay, so basically we have a vertical asymptote at x equals to 4. We have an asymptote at x equals to 0. Pretend that I'm drawing it down the right place. We know we have an x-intercept at x equals to 2. We know it crosses there. And we know we have a horizontal asymptote at y equals to 0. So that means along here we have a dotted line. Use dotted lines for your asymptote. Okay. So, first thing we need to check is, let me just make sure I've got everything under control. Of course, you should actually be labeling your graph. X, y, and c of x equals to x minus 2, and you should be using at least a ruler to draw your axes, so I'm not giving you a very good example. Okay, so we know it crosses here. Let's test values, that's the best way to do it. So let's test, for example, I don't know, let's test 1. Okay, it's very easy. So c of 1, negative 1 divided by 1 minus 4 gives us negative 3, which gives us 3. Okay, so we know at 1, it's actually going up like this. So it would be safe to say, and we will check, okay, we'll check c of 3. c of 3, okay, will give us 1. 3 minus 2 will give us 1. Over 9 minus 4 will give us 1/5. And Mr. Anthony, you're not exactly correct at this stage, because we know that it crosses at x equals to 2. Why are we getting 3 equals to 1 divided by 9 minus 12, which gives us negative 3, negative 1/3. So yes, it is moving down here slowly but surely. Okay, there we know that that's happening there. Now, And yes, it does actually cross the horizontal asymptote. Okay, if you test at x equals to 2, you will find that it is actually defined 4 minus 4 times 2, 4 minus 8, sorry, what did I just say? C of 2 should be 0 divided by something, which will give you 0, so yes, it does actually cross, and it is defined, different with the vertical asymptote where it never crosses, it's just a slight difference, okay? You need to test those things. Now, let's look at if we have, for example, I don't know, test C of 5. Where is C of 5? Okay, C of 5 equals to 3 over 25 minus 4 times 3, 25 minus 12, which gives us 13, which gives us a small number, okay? So obviously, as we're going along here, you can test other values. I'm almost positive that we're going to get something like this, because it's approaching the horizontal asymptote y equals to 0. I bet you if you test 4.1, okay, we can just check something like this. We don't have to check the exact values. Will give us 2.1, 4.1, let's just imagine it's greater than 16. 16 minus 16.1 will give us negative 0.1. So yes, it is getting, and no, Mr. Anton, you're actually wrong. 4.1 gives you 2.1, 4.1 squared gives you a bigger number than this. So actually, yes, you will get a positive. So it will be 0.1 and it will give you a massive number. So you're correct. Then we look on this side. If you look on the other side of 0, you will see, let's test negative 1. C of negative 1, sorry, my writing's all over the place. Negative 3 over 1 minus 4 times negative 1. 1 plus 4 gives you negative 3 over 5. That means that it's going, as you go along, it's getting, sorry, where are we? C of negative 1, it's getting closer and closer to here. And obviously you need to test something a little bit closer, 0.1 for example. Okay, just to be on the safe side, you don't need to put in the exact values. But 0.1 minus 2 is going to give us negative 1.9. 0.1 is going to give us an even smaller number. I'm guessing it's from memory, minus 0.4, which gives us a negative number, which means 0.1 minus 4 times 0. Oh, Mr. Anthony, what are you doing? C of negative 0.1, thank you, means that you'll get negative 0.1 will give you a negative approximately 2.1, and then this will give you a 0.01, and then that will give you a plus 0.4, and that will give you, say, 0.4, negative 2 point, negative 0.1, negative 2.1 divided by that is going to give you, my brain's just stopped, negative 5, for example. So yes, it is working. Okay, it is giving you, and there you go. You have it. There's your graph. Voila. Finished. That's question number 10 from memory on exercise 4.3. Over and out.